Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Golden Palindromes by Math Guy 12. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which in this case is a box. We have clues outside the grid provide the sum of the indicated diagonal. Digits may repeat along a diagonal if allowed by other rules. So this diagonal must add up to 11. This diagonal must add up to 22. This diagonal adds up to 22, etc., etc. So, for example, if this were, say, a 5, this would have to be a 6 because these two digits must add up to 11 along this diagonal. And that's an example of how, and these are called little killer clues. So that's an example of how little killer clues work. We also have digits in cages sum to the value in the top left corner. So, for example, these three digits add up to 19, these three add up to 20, these three add up to 18, etc., etc. This adds up to 22. So for example, this valid possibility for this 18 cage would be 4, 6, and 8 because that adds up to 18. And these three digits must add up to 18, which is the sum number in the top left corner of this killer cage. And finally, we have digits along a golden palindrome line are read the same from either direction. In addition, the central digit on the line, marked by a golden circle, is the same as the digit on the ends of the line. So this is a normal palindrome line. So it reads the same going this way as it does this going this way. But the digit in the circle must be exactly the same as the digits on the end of the palindrome lines. That's actually very interesting. So this must read the same going this way as it does going this direction. And this digit is the same as these two digits. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. So we know this digit is the same as these two. We're going to mark this as an A. So A. This will be B, 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 B. This will be C, 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 C. And we have D, D, and D here. Okay. Well, that's actually one interesting thing. We know, so by Fistemafel's ring theorem, we know that these 16 digits here is exactly the same digits as the digits in every 2x2 corner of the grid. So then these we know add up to 22. What does that tell us? I'm not sure. We know what this adds up to. So therefore, A cannot be the same as B or C. But it could be the same digit as D. We're just not certain of that. So A cannot be... Okay, so where can A be? Where is A in column 1? It cannot be here because if A's in the boxes. Therefore, it must be one of these three. And if it's here, it would have to be the same digit as that, and therefore cannot be A. So A has to be one of these two digits here. Where is A in row 2? Cannot be here because if A's in the boxes, so A has to be one of those two. Okay. B, similarly, cannot be, has to, where's A, B in column, in row 1? It cannot be these because of B's in the boxes. Can't be here because that matches that cell and B sees that one there. So B has to be one of those two. So A is here and A is here. Interesting. B can be, has to be one of these two in column 8. C in column 2 has to be, again, cannot be the same as A, so it has to be one of those two. C in cannot be here because then it would have to be here, and so can't be. So this is all very similar, right? D cannot be here because it would have to be here too, and then for we can't have that. So D's there. D in row 8 has to be one of those two. Okay. That tells us we have 18 plus 20 plus 19 plus 17. That is going to be 2 less, 2, 3, 4, and 5 less than the 22s in the corners. So that's a total of 14. So A plus B plus C plus D adds up to 14. We know, okay, so in each corner, we have an 11 along a diagonal. So this must be some combination of 11 and 11. So this is 2 through 9. And again, we have what? B here and C has to be here. These are all 2 through 9. Oh, that's interesting. Therefore, there is no 1 around this Fistemafel ring. Right? Because there is no 1 in any of the corner 2x2 era cages. Because this must be 11, and that must be 11 then, too. This adds up to 22. These digits are the same also, because of palindrome line. Interesting. So these two are the same digit, so there must be Z and Z. So A and Z twice adds up to 22. So A and Z must add up to 11. Same with B and Y here. Same with C and X here. And same with D and W here. What does that mean? I am not completely certain. We know this adds up to 11. This adds up to 11 here. So 1 cannot be either of these. In box 7, 1 has to be one of these two digits because 1 can never be around the Fistemafel ring because, again, we have these adding up to 11, 11. And 1 is here, 1 is here. 1 can be here or here, and 1 can be here or here, 1 can be here or here. What does that mean? I am not certain. Okay, so we know C and X add up to 11. Hmm. What else do we know? If 1 is here, so 1 could be here, and then 1's here, here, here. So what does that mean? So if 1 is here, that means 1 cannot be here, so it must be here, it must be here, it must be here. Well, we have 1 here and 1 here. It cannot be on the palindrome. Or can it? No. This digit is the same as this. So, I don't know. Let's go from E, I guess. E, F and F, G and G, H and H. This is I and I. J, wait, that can't be right. This is I and I. This is J and J. K and K. L and L. Okay. Does that tell us anything? I am not certain. Maybe that's not helpful. Oh, we still want the ones. So B is one of these two, which means Y has to be one of these two. A is one of these two, so Z has to be one of those two. C is here, which means X is one of these two. Because it must add up to 11, right? Okay, so where is... We have Y's here. Y has to be one of those two. B is here, so that means Y has to be one of these two to add up to 11. Which means Y has to be one of those two. Y can never be D because they are the same column here. Z. Z is with A to add up to 10, 11, so Z has to be here. Z and A are here. Z is one of those two. That means Z has to be one of those two. We don't know where else Z can be. We have B and Y, B and Y. This is B and Y, Y. C and X. X is one of those two. X has to be one of these two. So X has to be, cannot be here. X is one of these two, so X has to be there. And then we have W. W must add up with a D to add up to 11. D, and this is W. Which means W in row 7 has to be one of those two. Okay. Hmm. Can B be the same as X? Maybe. Hmm. We know B has to be in at least two of the boxes here. Um, hmm. So what happens with ones? Say this was 1. That would force this to be 1, this to be 1, that to be 1. 1 would have to be one of these three. It cannot be here because that matches that cell. Cannot be here because then that matches that cell. So then 1 would have to be here, if that's the case. This is the same reason. If 1 is here, that forces 1 to be here, and that's not allowed. If 1 is forced to be here, that would have to be here, so that's not allowed. So 1 is here. So we'd have 1 here, 1 here. Ah, and this wouldn't work. Because this would have to be 1 also, right? This can't be... If this is 1, that would force 1 here, which is not allowed. And if 1 were here, that would force a 1 in that position, which is not allowed. So we know 1 cannot be on the non-palindrome space here. So this is not 1, this is not 1, this is not 1, and this is not 1. So we're guaranteed this is 1, that's 1. This is 1, that's 1. Now on the palindrome, this has to be a 1 also, because it reads the same this way as it does the other way. This one means that has to be 1 there. This one means that's a 1 there. This one means that's a 1 there. So we should have 8 ones. We do. We know where the last one has to be. It has to be there. Okay. Hmm. We know X is in at least 2 spaces. It's guaranteed to be here. Cannot be on this row. Okay, so we got all the ones. We'll label this E's and F's. G, and these are H's. Okay. Okay, so B and C could be the same. B and X could be the same digit. Or they could be completely different combinations adding up to 11. Same with AW and AD, right? Same with ZW and ZD. Um, Hmm. Does that tell us anything? Not particularly. Hmm. Okay. Hmm. We know Z here and A add up to 11. We know B and Y add up to 11. Um, we don't know anything about E and F, really. F has to be one of these 3 digits here. E has to be one of those 3. G has to be one of these 3. Oh, that's interesting. Okay. That is interesting. Okay. Let's start coloring. So these two add up to 11. We're gonna mark that as what? Green? Maybe we'll mark it as pink. These will mark as green. These will mark as... So these two add up to 11. This is 1. Therefore, these two must add up to 11 here. That is interesting. So this is a set. And this is a set, adding up to 11. So we'll make it orange, orange. So these add up to 11, these add up to 11, these add up to 11, and these add up to 11. So these are the orange set. Z has to be one of these. B and Y have to be either green or pink. We're not sure which. That means F and the other digit here must add up to 11. So this is the other green and pink set. We don't know which. So this is green and pink, and there must be an orange here. Interesting. So we have one red, one orange, and one of the green or pinks add up to 18 here. So you'll have a same situation around each row 3, row 7, column 3, and column 7. Because we know these add up to 11, these add up to 11, these add up to 11, and these add up to 11. Okay. Is that helpful? I don't know. Um, hmm. So you're going to have something similar everywhere here. These two add up to 11. Hmm. Let's make... Okay, so... We'll make this green. So orange has to be here. And then we'll make this pink. So this has to be a pink-orange pair. F has to be one of these two. That's interesting. These two add up to 11, so this is pink and pink. Where is the other pink then? So since this is pink and pink adding up to 11, this is red and red. Where is red in box 3? It cannot be here, and it can't be B, and these two add up to 11, and it can't be pink. So this has to be orange and red here, adding up to 11. This is pink and green. Green is one of these two. So we have red and orange in the rest of this. And this can't be obviously red or orange. Let's just match these for now. That's interesting. So let's say blue and yellow then here. So we're going to make this blue and this yellow. So this is green or pink. This is orange, obviously. Yellow cannot be here. This must be yellow and blue. This is essentially red and orange also. So red and orange cannot be here. Therefore, one of these is red. And I guess we'll make it medium and dark here. So this will be medium and these will be dark. Which forces this to be medium here. This is medium. So this is dark and blue. Okay. That means F has to be here. E is here and here. That means E has to be here. Okay. This is blue. So that makes this green and yellow. F cannot be here, cannot be A or E, can't be Y or 1, so it's one of those two. E cannot be C or G, can't be here, can't be 1 or Z, so E has to be one of these two. We have G here, cannot be H or D, can't be 1 or X, can't be any of these, so G is here. Then H must be one of those two. So D and W add up to our blue. We have oranges here. These are green. These are medium. This is blue. H is yellow. G is dark. E is red. This digit must be the same as this. So this is red and green combination. This is, one of them's pink, and the other one is H. So this is pink and yellow. One of these is not D. One of these is this yellow here. And the other one is G, so it's dark. And this cannot be, this is E, so it's red, is one of these. And then the other one has to be, what are we missing? Can't be orange. What's the last color here? Is it medium? No, it can't be medium. It's dark. It matches this dark, so... Okay. Interesting. So, orange and red match yellow and blue here. Okay, so the letters don't help to... Oh, this is not F. We know F is one of these two. Should we match these? Maybe. Okay. E matches with... So, W, X, Y, Z, T, U, V. E matches with V. So this is specifically F and V here. This is F matches TU, so this would be FU. G matches with T, and H matches with S. So we know this is FV, this is UZ. Let's clear this. This is B and Y. So B is here and Y is here. And we have F and U. So U cannot be here. U has to be one of these two. And F is here. So this is a BF pair. This is UY. This is Y and S. This is H and U. Right, this is pink. Here has to be, oops. B has to be here. Y is here. We have F is here and U is here. This is W and dark. So it's T, TW. This is G and S. Okay. This way we have A and Z. And this is V, so this is E here. Oh. Well, there you go. We know this is V, this is E. So V must be here, and it corresponds to an E here. So this cannot be E, which means this is E guaranteed. This is red, essentially. This can't be red, it's dark, so this is T. Okay, so that's interesting information to have. A is one of these two, and then Z is one of those two. E is one of these two, and we have V here. So AV, EZ. This is X and V. V and X. So shouldn't this be F? Yeah, V cannot be here, so this must be F. Which means this can't be F, this is V. Why do I have this as green? This is not green. This has to be pink. And this is red. Okay. Similarly, this must be H. Right, because U has to be here, so this can't be U. So this is H, which makes this not pink, that's yellow. Which makes this not yellow, so that's U. This is then G, and this is S. So G is the dark, so not yellow, and this is not dark. Okay. Interesting. Does that match? Yeah, so each of the pinks and greens should be twice in this Fistamethel's ring. Again, green and pink match blue and yellow. So we have green, or no, sorry, green and pink match dark and medium. Okay. So green is here and here. And then medium's here, here, dark is here and here. So we're guaranteed twice there. G cannot be here or here. So green and pink match medium and dark. Orange and red match blue and yellow. Okay. Okay, we know A cannot be here and A cannot be here. So A has to be one of these three cells. Interesting. That means if A were D, it could not work. Does that tell us anything else? I don't really know. Z cannot be any of these. That's interesting. So if Z were here, what happens? A would have to be one of these three, and Z would have to be one of these three. Well, interesting. So if A can't be any of these, obviously one is here. A would have to be one of those three. If Z also has to be one of these three, it cannot have A and Z here because blue and yellow are both here. And so this would have to be A or Z, which means blue would not be A or Z. So that means... But the thing is, we don't know that that assumption is correct, right? Huh. Huh. Okay. Let us try to make that assumption and see if it leads to any contradictions. Oh, that's interesting. Huh. So that would mean orange cannot be either of these. So orange has to be here and here. It has to be one of these. And it has to be here, guaranteed. So orange is not blue. So then blue would have to be red. And yellow would have to be orange. But then this couldn't be orange, so that would be green, which means this can't be green, so that would be orange. So we have two oranges here, so that couldn't be orange, so we know we have oranges here. Okay, that means this can't be red. That means this can't be medium. So far, that's looking okay. Green cannot be either of these. So that means green cannot be here. Green would have to be both of these. Which means medium could not be green. So medium would have to be pink. And then dark would be green. So this can't be green, so this would be red. This can't be red, so that would be green. Okay. So then this would be, I think... we have two greens, two pinks, so this would be red. And this would also have to be red, too. Because red cannot be here. So then that's red, red. So far that looks fine. This is pink, pink. So that looks fine. What happens if we do the other way? So assume this is not orange. So this is pink, which means this can't be pink, that's orange. So Z cannot be any of these. Let's try to make blue orange. See if that works in that scenario. Orange cannot be here. D cannot specifically be here or here, and it can't be here. So this would have to be orange and a D. Which would mean D matches Z, if that's the case. This would be Z. So that would be technically D. A could not be here or here or here, so A would have to be here. So this would be orange, orange, which means this could not be orange. This is dark, this can't be dark, so that's orange. Then you're going to have a similar situation here, I think. Yellow then is matching red. Okay. We have two reds here, so this cannot be red. This can't be red. So this can't be medium. This can't be green. We have two reds here in column 5. E is not the same as H. So E is the same as S. So E cannot be here or here, so it's one of these two. Okay. We'd have orange, orange here. Hmm. This is orange and orange. So green has to be one of these two. What does that mean? We have two reds here. Does that mean pink is the same? F can't be here. F can't be here. F can't be here. Okay, so this is W. This is T. No F. No F. This is U. Z. Okay, so W is equal to A. And D would match Z. So this would be A, that would be Z. We don't necessarily have to have these be the same. Yeah, we were just making blue the same as orange. That's essentially the assumption here. But we don't... Okay, so... medium, again, has to be either... medium and gray match up to green or pink. So this is medium, medium, so this cannot be pink, which means mediums are all green. So those are green. And darks are all pink. So then this is F, this is U. So all the G's are U's and all the T's are F. Okay, so this has to then be green and green here. This is, so this is not B. This has to be Y. This is S. H's match with V's, and S's must match with E. So this is B here. C's must match with Y. X's match with B. Okay. I mean, that looks like it works too. So this is B, this is Y. I mean, it seems like that works fine. E, this is V. So B cannot be here, so this must be F, which makes this U. This is B and Y. So these are F and U are pink, and B and Y are green. V cannot be here, so this is Z, this is V. Z and A add up together, so then these are both not red, and these are both not yellow. So this is E. So this works also. Dang it. Huh. So we don't have any contradictions right now. I'm gonna pause. I need to go to the bathroom right now. I'll be right back once I get this back to... Oh wait, this is fine. And then it was, yeah, that's fine. This is fine. That's fine. And then it was this assumption. Okay, I'm gonna pause. I'll be right back. And I'm back. Okay, it's getting kind of dark here. Let's try to finish this up. Okay. So say the yellow here is actually the orange. So this cannot be orange. This would be green. This cannot be green. That would be orange. That means we have two oranges here. Oh, sorry, two oranges here, two oranges here. Blue then would have to match red. So that would be red. This could no longer be red. That would be medium. This can't be medium, so it's red. So this would be V. This would be X. We have two greens here. So we have two reds, two oranges. We don't have this assumption here. So none of these are orange. So we have two oranges in 3 digits here. The last one is dark. So this is two oranges and a dark here. Here would be not orange and not red, which means this is some combination of blue and green and pink. This can't be green, so this would be pink, because those are both green. So this would be pink and pink, which means this would be green and dark would have to be green. So dark is green. This cannot be green, so that's an orange there, which makes that orange. These are all green. The medium must be pink. So this is pink and pink, which means this can't be pink. So this is orange, which means it can't be orange here, so it's pink. So far, that's still the same. This cannot be orange, that's green, which means this can't be green, that's orange. That leaves this as pink and pink. This has to be, this can't be green, that's red, which means this can't be red. So that's green, that makes this red and red. Okay, so if we make the assumption of either way, we come up with both scenarios. We just have to figure out which one is the incorrect scenario, but they both look fine. Okay. Okay, let's see if I wasn't running into any contradictions in the other one, so let's try this. So this is Z, we have U, this is C, this is F, which makes this U, that's F. This is H, and that's S. This is G, and that's T. This is B and Y, so this is S and H. I don't know. G and T, which makes this W. E, V, V, E. There doesn't seem to be a contradiction here. So we have green here. In this scenario, we have red, green, pink, and orange. Okay. Hmm. Interesting. That is interesting. Okay, so these are three distinct, no matter what, these are three distinctly different sets that add up to 11, right? 2, 9, 3, 8, 4, 7, and 5, 6 are the distinct sets. So is this. Mm. What does the 20 have to be? You can't have any set that adds up to they can't be in the same set. So 389 works. No, 389 does not work because 3 and 8 are in the same set. That adds up to 11. Um Anything with 9 does not work because the other two digits add up to 11. So that means you have to drop the 9. So 5, 7, 8. Yes. Okay, this is probably how we solve it then. So we know these are all distinctly different sets, guaranteed. This then I think has to be 5, 7, 8, right? You cannot have a 9 there. Because if you did have a 9, okay, so again, if you have 9, the other two digits add up to 11. So 3, 8, 9's ruled out. 4, 7, 9's ruled. Anything with 9 is ruled out. 5, 6, 9 is ruled out. And we're guaranteed to have 5, 7, and 8. So this has to be 5, 7, and 8 no matter what. We have 5, 7, and 8. So green and yellow. Yellow, so one of the oranges is 2 and 9. This is 5, 7, 8. This is 19. And the other one then has to match the yellow here. So this is guaranteed to be 5, 7, 8. You cannot have an 8 here, because if you had an 8 here, the other two digits would add up to 11. We are guaranteed yellow here and a blue here, which means we either have a 2 or we have a 9 here. Because this is 5, 7, 8, which leaves out the blue. The blue has to be 2 and 9. So this is 5, 7, 8. This is a 2, 9 pair. So D and W are 2 and 9. Let's move. So this is 2 and 9 here. So we have a 2, 9 here. This is H. It cannot be 5, 7, or 8. It's the opposite of that. Right? Because we have the other yellow here. So this must be, if it's 8 here, it matches here. This must be 3. If it's 7 here, that's 4. If it's 5 here, this is 6. So this is 3, 4, and 6 specifically. This is also 3, 4, and 6 also. We have dark. That's not helpful. So it's a 2-9 pair. This is 5, 7, or 8, adding up to 11 with this. So we know this is 5, 7, 8. Can you ever have 2 here? No. If this is 2, this is at most 6. And 2 and 6 add up to 8 with 11 does not add up. So this has to be a 9. So this is guaranteed to be 9, which makes this a 2. Therefore, this is 9. This is 2, 2, and that's 9. How do I get 6 here? This is 9. Okay. So this is 9, which means the other 2 must add up to 10. We don't know what this is, though. So this is either 3 and 7, or it's 4 and 6 here. Okay. So we're guaranteed a 9 is here. This is 2 and 9. Therefore, we know we have a 2 here and a 9 here. We're not sure which. This is also 5, 7, or 8. Oops. This is also 3, 4, or 6. Okay. This adds up to 18. Huh. So the H's are 3, 4, and 6. And the S's are 5, 7, and 8. Okay. Two is here, 2 is here. So 2 has to be one of these 3. We know 9 is one of those 2. This is some combination of 3, 4, 5, 6, 7, 8. Two and 9 cannot be here. But 2 and 9 could be here. Can you have 2 here? I think the answer to that is no. Right? Because if you had 2 here, what other digits have to add up to it? It has to be 7 and 9. And we know these are different sets. So 2 is guaranteed to be 8, A or V. So that means 2 has to be one of these 2. Which means this can never be 2. So 2 has to be here, which makes this a 9. So this cannot be 9 here. So this is 2. And this is 9. 2 has to be one of these 2. Has to be one of these 2. So it's A or V. So that means 2 has to be one of these 2 here. Okay, 2 cannot be here. Cannot be here. So 2 is one of these 2. And 9 has to be one of these 2. Okay. Can 2 be here? Two, 7, and 8? Yes, that could work. This would have to be guaranteed 2, 7, and 9, so that's why that didn't work. Hmm. So this is A or the other A or V, and this must be E or Z to match, but we don't know which. Okay. So this has to have a 9 here somewhere. So since this is 9, what is that combinations then? You can have 9, 3, 6 works, and 4, 5 works. So those are the possible combinations. Either way, okay, so that makes sense. So since this is 9, this is guaranteed to be 3, 6, or 4, 5, because again, you can't have a 1 there, and you can't have 2, because they would be in the same set. Either way, this cannot be 5 and 6. If this is 5 and 6, that would eliminate all possibilities for this cage. So this has to be 3 or 4 here. So this is 3 or 4. This is 7 or 8. This is 3 or 4. This has to be a 7 or 8 here for the green. Hmm. So 7 and 8. So this is 3 or 4 here. So this is the other 3, 4. Hmm. So this is 3, 4, and 7, 8. Oof. Doesn't really tell us much, right? We do know the other 3, 4s here. So this is 2 with 7 or 8, or 5, 5 or 6, right? That doesn't tell us too much, unfortunately. Now 2 could be here. It would be 2, 7, and 8 if that were the case. Interesting. Oh, yes, this cannot. Well, we know 2 is in each, is twice. 2 and 9 are both twice in the corners. So we know 9's here. We know 9's here. So 9 cannot be part of this. But 2 could be here. That is the issue, right? 2 is not guaranteed to be here. This does not have a 9. Oh. This is either 3, 6, or 4, 5. Huh. What does that mean? I don't know. Okay. Yeah, this is kind of tough. So this is 5, 7, or 8. This is 5, 7, or 8. Hmm. Hmm. Okay. Huh. Hmm. So this is 2, 5, 6, 7, 8. All right. Okay. What happens if the red is the 2? So this is 2, that's 9. That would be 2 and 9. So this would be 3, 4, 5, 6. That means 2 would have to be here. This would have to be 2, 7, 8, which eliminates 2, 7, 8 here. Oh, that's interesting. So either this is 2 or this is 5 and 6. Interesting. Obviously, this can't be 2. This can't be 2, so this would have to be 2 here. So you'd have a 7, 8 pair. That means this would be 5, 7, 8. This would be 7, 8, so this could no longer have 7 and 8. So this would have to be 4, 6, and 9. Okay. Which means this couldn't be 4, 6. So that means this pair is not 4, 7, it's not 5, 6. This becomes 3 and 8, which forces this to be 7. That's 8. This matches this, so this would be 8, which would force that to be 8 and 3. That makes this 8, 3. Okay, so that works. This can't be 7 or 8, so it's 5, that's 6. Which makes that 6 and that 5. This is not 6, this is 4 and 9. So dark must be 7. So this is 7. That matches. This is 4. Okay. We have a 5 here. One of these is 5. We don't know which. So that seems to work. So, one thing we do know then is this has to be 5 or 6 if it's not 2. If it's 2, obviously this is 2. So what happens if we make that 2, actually? So that's 2, that's 2, that's 2. That makes this 9 and 9, so this cannot be 9 here. That means 2... Ah, we have a contradiction. Right. Okay, so that is the contradiction. So, if we have V being 2, or A being 2, that means this is 2, that's 2, which eliminates all possibilities for 2 in box 5. So, this cannot be 2. Therefore, we know E is the 2. Where is this E? I think this was E. V is a 2. So this is 2, that's 2, which forces this to be 5 or 6. V has to be 2, cannot be here. So this is not red. This is medium. This is therefore the 2, and E is 9. So E is 9, that's 9. This cannot be 9 here. To add up to 17, this has to be a 7-8 pair. So this is 7 and 8. Which means these are 3 and 4. So that matches here. This is 3 or 4. We have 7 and 8 here once, 7 and 8 here once, and because of Fistimafel's ring, you cannot have 7 in the rest of the ring, because it must match these sets, and we only have 7. Each of the pairs that add up to 11 are only in each set twice exactly. So this cannot be 3, 7, and 9. It must be 4, 6, and 9, which eliminates 4, 6, and 9. So this in the rest of the rows. So this is 4 and 6. This is 4, 6, 9. This has to be 7 or 8. The 7, 8 pair eliminates 7 and 8 here, so this is 5. That's 6. This must match here, so that's 6 and that's 5. Therefore, this can't be 6. It's a 4, 9 pair, which eliminates 4 and 9 in the rest of the row, so this can't be 4. That's 3, which matches that, so that's 3, that's 3. Therefore, these must be 8, and this must be 7. G matches here, so that's 7, that's 7. This is 4, that matches here, so that's 4. 2 cannot be here anymore, so this is 2 here. So blue matches red. So this cannot be 2 here or here, which makes this a 2. So this is blue. This is 6. So this is 5 or 6, this is 5 or 6, so this cannot be 5 or 6. It's 3, 4 with 7 or 8. That means this is 3, 4. This has to be 5 and 6. This can't be 6, so this is 5, which makes that 6. Which makes this not 6, so it's 5, which matches here, so it's 5 and 5. That makes this 6 and 6. So this cannot be 4 and 5, it's 3, 6. Which means this can't be 3, that's 4, so this must be 4 and 7, adding up to 11. So that's 4 and 7, 7, 4. This can't be 7, it's 8, makes that 3. So this can't be 8 here, this is a 5, 7 pair. This matches here, so this is 8 here, this is 3. This matches here, so this is 8. 4 eliminates 4 here, so this is 9. That's 4. This cannot be dark. It's blue, which means this can't be blue. That's dark. This 3 eliminates 3 here, so that's 6 and 3, which means this cannot be pink. This is orange. This can't be orange. It's pink. And so we now know darks are green. This is 9 to add up to 11. Reds. I guess we should just match blue. Blue is red. Yellow must match with orange. And mediums match with pink. Okay, so then these are both red. Cannot be orange. These can't be orange, or they can't be red, so they're orange. That makes this 5 and 6. 3 cannot be here or here, so this must be 3 here. That makes this 8, so these are pink and not green. This cannot be pink, so that's green. Therefore, this is 4, and this is 7. This has to be 8. 8 cannot be here or here. So this must be 8 here, which makes this a 3. So these are both pink, not green, and these are not pink, that's green. That forces this to be 4 and that to be 7. This 5 eliminates 5 here, so it's 7 and 5. This can't be orange. This is green. This can't be green. That's orange. Okay. That means 9 cannot be here or here. This is 9. Okay, so this is then double reds, which makes this double not orange. This is orange here. So this must be double orange here. This has to be double pink, and this must be double green. So that makes 2, 9. Oops. 2, 9. This is then 3 and 8. This is then 5 and 6, and this is 4 and 7. And that's the solution. Pretty cool, actually. Very nice use of these golden palindromes, which I've never run into before. And we had to figure it out from the cages, which was interesting. So basically, you got to a certain point, and then you're just kind of stuck until you basically start figuring out what these can be, right? What these cages are. Otherwise, you're just going to be stuck for basically all time, because you have to have the actual cages disambiguate things. But that was pretty interesting. Nice little use of these clues to basically guarantee you knew what these had to be in a set, right? Overall, very well created puzzle. I enjoyed it a lot. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.